Hey y'all, it's Sarah. Welcome back to my Calculus 1 series. Today we are going to be talking about indeterminate forms and L'Hopital's rule, which is the topic that the next couple videos are going to focus on. So I'm going to motivate this with a little example. So we're going to try to solve this limit by direct substitution. So we're going to sub in 0 for x. So we obtain the natural log of 0 plus 1 over 0, which is the natural log of 1 over 0, and the natural log of 1 is just 0, so this becomes 0 over 0, right? In terms of solving for the natural log of 1, think of it as finding e to the what power equals 1, e to the 0 power equals 1, right? So that's why it's 0. So 0 over 0 is something that we call an indeterminate form, okay? When we find 0 over 0 or infinity over infinity, that is a sign to us that we need to do something else in order to actually solve for the limit. And L'Hopital's rule is the trick that we're going to use for this. So basically, L'Hopital's rule states that if we are taking the limit of a quotient of two different functions, and that limit gives us either 0 over 0 or infinity over infinity, then if both the numerator and the denominator are differentiable and the derivative of the denominator is non-zero, since we can't divide by 0, then we can solve this limit by just replacing both the numerator and the denominator by their derivatives. Now keep in mind, we are not taking the derivative of the whole thing using quotient rule. Instead, we are individually taking the derivative of the numerator and the derivative of the denominator. Okay, so this is not quotient rule. Don't get that confused. So back to our previous example. At this step, we're going to apply L'Hopital's rule. So whenever I apply L'Hopital's rule, I just write LH over my equal sign. So now this is going to be the limit of the derivative of ln of x plus 1. So d dx ln x plus 1 over the derivative of x. Now, the derivative of natural log of x plus 1 is going to be 1 over x plus 1. And then the derivative of x is just 1. So this becomes the limit as x approaches 0 of 1 over x plus 1. So now, if we sub in 0, we have 1 over 0 plus 1, which is 1 over 1, which just gives us 1. All right, now for another example. Again, here, if we just sub in 0, we have sine of 0 over 0. Sine of 0 is 0, so we have the 0 over 0 indeterminate form. So we're going to L'Hopital this. This becomes the limit as x approaches 0. The derivative of sine is cosine, and the derivative of x is 1. So this is just the limit as x approaches 0 of cosine of x. We can sub in 0, cosine of 0, and cosine of 0 is 1. So that is our limit. Now we're going to look at the infinity over infinity case. So if we sub in infinity here, we have infinity over e to the infinity. Now e to the infinity is infinity. If you look at the graph of the function e to the x, this will become clear. But this means that this is the infinity over infinity case. Now, that means that we can L'Hopital. So you have the limit as x approaches infinity of the derivative of x, which is 1, over e to the x, because the derivative of e to the x is always itself. Now, if I plug in infinity, I'm going to have 1 over e to the infinity. Again, e to the infinity is infinity, so we have 1 over infinity, and a constant over infinity is just 0. So that's going to be our limit. Now, sometimes we have to L'Hopital more than once, and that's what we're going to see with this problem. So if we plug in infinity here, at the top we have infinity cubed minus infinity squared plus infinity minus 3. It's going to come out to just be infinity. And then like we said earlier, e to the infinity is infinity. So this is a case that we can L'Hopital. So when we L'Hopital this, we're going to have 3x squared minus 2x plus 1 over e to the x. Now, if we plug in infinity again, here, we're going to still get infinity over infinity because we still have x's in the numerator. So in this case, we L'Hopital again. And we're just going to keep applying L'Hopital's rule until we get something that is not indeterminate. All right, we still get infinity over infinity. So we're going to L'Hopital one more time. Now we have 6 over e to the x. So when we plug in infinity, we're going to have 6 over e to the infinity. That's 6 over infinity. Any constant over infinity is 0. So that is our limit. Now, 0 over 0 and infinity over infinity aren't the only types of indeterminate forms, but they are the only types of indeterminate forms that we can apply L'Hopital's rule to directly with no manipulation, okay? There are 3 other types: indeterminate differences, indeterminate products, and indeterminate powers. And I'm going to dedicate an individual video to each of these to talk about how we deal with these types of forms. So stay tuned for those next 3 videos. I'll see you all next time. If you enjoyed this video, please like and subscribe.